try number 5 on your own. What's the limit as b approaches infinity of negative cosine b? Yeah, it's oscillating between -1 and 1. So what can you tell me about that limit? It doesn't exist. So if I take something that doesn't exist plus 1, it still doesn't exist. So because this limit does not exist, the integral diverges. So the improper integrals in example 2 and 5 diverge for different reasons. In example 2, the improper integral diverges because the region to the right of 1 between the graph and the x-axis has an infinite area. In example 5, the improper integral diverges because of the oscillation of the sine function. And sometimes this is called divergence by oscillation, because if you were to graph the sine function, you're going to get that right there. So what you're finding all of those areas, but forever and ever and ever. And at first glance, you might think that the sum of that, or that integral, would equal 0, because the area above the x-axis and the area below the x-axis are the same. But it just it all keeps going on and on. So it depends upon where infinity never stops. So yes, this and this are going to cancel out. But if you stop after this, you're going to have a positive number for your integral. If you stop after this next one right here, you'd be back to 0. So you never know where infinity would stop. We need to take the limit as b approaches infinity, integral from 1 to b of 1 minus x times e to the negative x dx. So our next task is to integrate that bad boy. Okay, Megan's suggesting by parts. What do y'all think? Yes. Do you want to use the table method, or do you want to just use u and dv? Okay, the table would work great. Because if we were using the table method, we have to let u be the part whose derivative will go to 0, so that has to be 1 minus x. dv will be e to the negative x, and that is something I can integrate, so I'm good to go. All right, so the first derivative is -1. The second derivative is 0. The integral of e to the negative x is negative e to the negative x. And if I integrate that again, I'm going to get positive e to the negative x. Don't forget your plus, minus, plus, etc. All right, so that integral is going to equal negative e to the negative x times 1 minus x. And then my double negative here is going to cause that to be plus e to the negative x, evaluated from 1 to b. Okay, if I plug in my b's, y'all okay with negative 1 minus b over e to the b? Just bring that e to the negative b down to the bottom. Plus 1 over e to the b. Minus, when I plug in a 1, for the first part I'm going to get 0. Right, minus 1 over e. or I'll eventually get minus 1 over e if I distribute that negative. All right, limit as b approaches infinity. On top, I am going to get, by plugging in infinity of this first fraction, what am I going to get when I plug in infinity? I'm going to get negative times 1 minus infinity. So that's really infinity. And over e to the infinity is infinity over infinity. No, that's not 1. Y'all didn't do your homework last night. We have to do, it's indeterminate, so we have to do L'Hopital's rule. Let's go ahead and check the rest of these right here. What about 1 over e to the b? As b approaches infinity, what's going to happen with that? That's 0. Okay, so we can knock that guy off right now. And then I just also have this minus 1 over e over there, and that's just a number, so I'm going to hang on to that. Okay, so I've got to do L'Hopital's rule, which means that for the part, and I only do L'Hopital's rule on the part that's indeterminate, so it's just this part right here. What would the derivative of the top part be? What's the derivative of negative 1 minus b? 1, right. And the derivative of e to the b is e to the b. So now as b approaches infinity, 1 over e to the infinity is 0, minus 1 over e is negative 1 over e. That's pretty much all you've learned in calculus this year. Integrating, we had to use integration by parts, taking your limits, you had to use L'Hopital's rule. Well, it's not everything we've learned, I guess, but yeah, that's our answer. So if we were to graph 1 minus x times e to the negative x, and then bound it from 1 to infinity, that area that's enclosed by that boundary is negative 1 over e. So obviously the majority of that graph is below the x-axis, or negative, yeah. All right, one more. How's this one different? Okay, it's one of those double ones. I'm integrating from negative infinity to positive infinity. Now, I can only deal with one improperness at a time, so I'm going to have to find some number to split this up. 0 is the perfect number to do that. So what I am going to do, because the integral from negative infinity to infinity would be the same thing as the integral from negative infinity to 0 plus the integral from 0 to infinity. Probably yes, you will always use 0. So I am going to take the limit as a approaches negative infinity and integrate from a to 0, e to the x over 1 plus e to the 2x, plus the limit as b approaches infinity, integral from 0 to b of that same thing. These are kind of a pain, but at least you're integrating the exact same thing in both integrals. So once we go over and figure out what that integral is, we can use it twice. Which, speaking of, how are we going to integrate e to the x over 1 plus e to the 2x? Okay, first thing someone suggested is natural log. If it was natural log, we'd take the derivative of the bottom. The problem is that the derivative of the bottom would be 2e to the 2x. The coefficient of 2 is not a problem, but the e to the x and the e to the 2x is a problem. Okay, I did hear somebody say the right thing over here. Brian? Well, Brian's not the answer, but I think Brian suggested the correct method, arctan. Okay? Arctan is an a squared plus a u squared on the bottom. A is 1. U is what? Just e to the x. And therefore, du is e to the x dx, which I've got up there. So what I'm really integrating is 1 over a squared plus u squared du, which is 1 over a arctan u over a. So it's just arctan e to the x. Everybody okay with that? All right, now it's just a lot of notation. So arctan e to the x from a to 0 plus the limit as b approaches infinity, arctan e to the x from 0 to b. Okay, so using my limits of integration, I'm going to have arctan e to the 0 minus arctan e to the a. And y'all can do all this, you just got to be really, really, really careful. What is e to the 0? 1. So what angle has a tangent of 1? Pi over 4. Minus e to the a as a approaches negative infinity would be like arctan of 1 over e to the infinity. Yeah, if a is approaching negative infinity, then I have e to the negative infinity, so 1 over e to the infinity, which 1 over e to the infinity is 0, and the arctan of 0 is 0. Okay, e to the b as b approaches infinity would be infinity, so arctan of infinity, or the limit as the arctan of x approaches infinity, is pi over 2 because of that arctan graph. Oh yeah, there is a plus between the two parentheses, thank you. Okay, remember your arctan graph where the asymptotes are pi over 2 and negative pi over 2. All right, and then e to the 0, once again, is 1. So the angle that has an arctan of 1 is, or the angle that has a tangent of 1 is pi over 4. Right, so we have pi over 4 plus pi over 2 minus pi over 4, which is pi over 2. That is as hard as it will get, I promise. And it's so much is about the notation, so you just have to remember to write that limit. You have to remember to start by taking the limit and then continue to write that limit.